Well, good evening friends. Well, in the last video we saw what is a median and some of the properties related with median. Now in this video we will find out that the centroid divides the median in the ratio 2:1. Okay. Now let's see how should we go about it. Now if you take any triangle, let's say we have triangle ABC. Now if you join this vertex with the midpoint of the opposite side, let's join it. Say this is the midpoint. Since D is the midpoint of side BC, so AD is the median. Okay, we also proved to ourselves that any median divides that triangle into two equal areas. Therefore, area of triangle ABD will be equal to the area of triangle ADC. This is what we saw in the last video. Even we proved it to ourselves. Now since there are three vertices in a triangle, therefore there will be three medians. Now this is the midpoint, this will be equal to this. Now the third median, let's call this point as F. Now we saw in the last video that the three medians of a triangle are concurrent and the point of intersection of the three medians is known as centroid. We labeled it as centroid. Now another important thing, another neat property that is related with the median is that the three medians divide the larger triangle ABC into six triangles, into six smaller triangles whose area are equal to each other. I mean these six smaller triangles are equal in area. Therefore, you can say that each triangle is having 1/6 of the area of triangle ABC. Okay. Now here what we have to prove that the centroid G divides the median in the ratio 2:1. So what we have to prove is BG is to GE is 2:1. In other words, you can say that BG is equals to twice of GE. Now this is what we have to prove. Now to prove that, let's see how should we go about it. Now if you focus upon the triangle ABE, and if you flip it clockwise, now this is how it will resemble. Now this is how it will resemble. This is B, this is E, and this is A. Now this is A, while this is G, and you join AG, and the point F lies on the side AB, where F is the midpoint of the side AB. Therefore, this is equals to this. Now this is what we get from this triangle when we have focused on the triangle ABE. Now from the last video, we know that the area of a triangle AGE is half of the area of triangle ABG. Why? Because the triangle ABG is consisted of two smaller triangles, FBG and AGF. So if this is X, this is also X, this is also X. So we can clearly see here that the area of triangle ABG is twice the area of AGE. Now this is the principle which will come in handy for us to prove that BG and GE is in the ratio 2:1. Okay. Now if you have to find out the area of AGE का जो area है, that is half base. What is base? GE is the base. And what is height? Height is nothing but a perpendicular drop from the opposite vertex. Let's call it as H. This is what? Equal to X. What is the area of ABG? Area of ABG is nothing but half base. Base is what? BG into height. What is height? Height will be same. The height for the area of the height for the triangle ABG is same as that of the height of triangle AGE, क्योंकि परपेंडिकुलर जो डिस्टेंस है वो सेम ही रहेगा, तो ये भी h होगा, but this is equals to 2x. Now let us substitute the value of x in this expression. So half bg into h is equals to 2x. What is x? Half into ge into h. Now h goes away, this 2 goes away. From here you can clearly see that bg is equals to twice of ge. Now here we can clearly see that the centroid divides the median in the ratio 2:1, or in another way we can say that the bg is twice the side ge. So this is what we had to prove, and we have proved it now. Okay, so that's it for this video. In the next video we will find out something interesting more related with median. Thank you.